Hello again, students. This is Mr. Reeves back with you as we continue to work our way through the Grade 7 CAASPP Math Practice Test. We have worked our way up to number 23, so let's go ahead and dive right in. It says Maria claims that any fraction located between 1/5 and 1/7 on the number line must have a denominator of 6. Enter a fraction that shows that Maria's claim is incorrect. All right, so I'm going to go ahead and make a sketch here of a number line. And I'm going to put 0. And way over here, to leave myself lots of space, I'm going to put 1. And the reason that I put 0 here and 1 here is because 1/5 and 1/7 are between 0 and 1. When you have a fraction, the top part of the fraction is called the numerator, and the bottom part of the fraction is called the denominator. And the top part of the fraction, the numerator, tells you how many you have. And the bottom part of the fraction tells you how many to make a whole. So if I have 1 out of 5, that means it's going to take 5 pieces to make a whole. So I'm just going to sketch here. All right, I didn't do a very good sketch, did I? So, all right, I'm going to make this 1/5. That would make this 2/5, 3/5, 4/5, and that would make this 5/5. So that's 1. All right, so 1 out of 5 means I have 1 out of 5 of these pieces that it would take to make a whole. So again, this would be 2/5, this would be 3/5, this would be 4/5, and this one right here would be here. I'm going to put the 1 here, and right down here, I'm going to put 5 out of 5. So this one would be 0 out of 5. And this up here would be 0. So we'll make the bottom ones all out of 5. So 1/5. This would be 2/5. This would be 3/5. This would be 4/5. And that would be 5/5. So right here we have 1/5. All right, so there's our 1/5. Now where would 1/7 be? Well, let's ask ourselves, is 1/7 bigger or smaller than 1/5? Well, 1/7 says I have 1 out of 7 to make a whole. So one of the things we like to do when we talk about fractions is talk about pizzas, because we can all associate cutting a pizza into pieces. Well, if I have one pizza and I cut it into 5 pieces, and I have a second pizza of the same size and cut it into 7 pieces, which pizza is going to have smaller pieces? Which one's going to have bigger pieces? Well, the 5ths are going to be bigger and the 7ths are going to be smaller. So if it takes 5 to make a whole for this one, 1/7 is going to be somewhere in here. And I'm just going to do a sketch right here. This is not accurate, but I'm going to put 1/7 as here and say, okay, that it would take 7 of these to make the whole. So there's 1/7, there's 1/5. And if I were to ask you what is a fraction that is between 1/7 and 1/5, if I were cutting these pieces and I wanted pieces that were bigger than the 5ths but smaller than the 7ths, well, I could do a 6th. And do you guys agree that 6 is between 5 and 7? I sure hope you do. So 1/6 is between 1/5 and 1/7. And that's what Maria was saying. She was saying, hey, if I want a fraction between 1/5 and 1/7, I'm going to go with 1/6. And that part is true, except she said that any fraction between them must have a denominator of 6. Well, any fraction with a numerator of 1 between them would. But let's look at those fractions here. So let's take 1/7. Let's take 1/5. 1/5. And let's look at 1/6 there. So I actually meant to make that green. I can't erase in there and make it green. Can I draw over it with green? Doesn't look very good, does it? We'll pretend. All right. So hopefully you guys know that you can take a fraction and come up with an equivalent fraction by multiplying by any constant in the numerator and the same constant in the denominator, because what you're actually multiplying by is the number 1. If you guys ever seen that before, that's a lousy number 1. All right, so I'm going to multiply 1/7 by 2/2, and what do I get? I get 2/14. So 1/7 is equivalent to 2/14. Then I'm going to take 1/6, I'm going to multiply it by that same 2/2, and I'm going to get 2/12. And then you know what I'm going to do next. I'm going to take that 1/5 and multiply by 2/2, and I'm going to get 2/10. So having 2 out of 14 is the same as having 1 out of 7. Having 2 out of 12 is the same as having 1 out of 6. And having 2 out of 10 is the same as having 1 out of 5. Well, guys, and girls, what is true about this number? 2/12 is equivalent to 1/6. But where was 1/6? 1/6 was between 1/7 and 1/5. So 2/12 is also between 1/7 and 1/5. And guess what? It does not have a denominator of 6. So Maria was on the right track with that 6 in the denominator, but she was incorrect. So we can put the fraction 2/12. Whoops, what happened there? Let's try that again. We can put the fraction 2 in the numerator, and we can put 12 in the denominator. And that is a counterexample to Maria's claim. And that is just one correct answer for number 23. All right, number 24. A company makes 2 sizes of box shaped like rectangular prisms. The large box is 16 inches tall, 10 inches wide, and 10 inches long. The drawing shows the dimensions of the small box. Part A. What is the maximum number of small boxes that can fit inside the large box? Part B. The company plans to increase the width and length of the large box by 4 inches to create a new larger box. How many more of the small boxes will be able to fit inside this new larger box compared to the original large box? All right, so I'm going to go ahead and take advantage of the fact that this box is pretty large, and I'm going to pretend that this is my larger one, and I'm going to draw a smaller one. Now, I'm going to have to tell you that it's not going to be to scale. So I'm going to do my best to make it look similar, but it's not going to be to scale. This is just a sketch. All right, so this is going to represent, again, my smaller box. So I'm going to take these dimensions. So the smaller box is 4 inches tall and 2 inches wide and 2 inches long. And I'm going to go ahead and change this one to my larger one. So the larger one, it says, is 16 inches tall, and it is 10 inches wide and 10 inches long. All right, so the question is, for part A, what is the maximum number of these smaller boxes that can fit into the larger box? All right, so let's take a look going across the front first. All right, the larger box is 10 going across, and the smaller one is 2 going across. So if we take a look at that as the width, 10 divided by 2 is 5. So we could get 5 small boxes going across that way. Okay? All right, what about the length? Well, the length of the larger box is 10, and the length of the shorter box is 2, and 10 divided by 2 is still 5, which means we could get 5 going this direction as well. So if we could get 5 boxes across and 5 boxes that way, how many total boxes could we fit along the bottom? And the answer is 5 times 5, or 25. So using length and width alone, we could get 25 boxes in. Each one of those boxes would be 2 by 2, right? Can you picture a box here, right here? 2 by 2. And we could fit 5 that way and 5 that way. And that would be 25 of those smaller ones. Okay, but what about up and down? Well, the height of the large box is 16, and the height of the smaller box is 4, and 16 divided by 4 is 4. So that means we could only get 4 going up. Like I said, this is not to scale. All right, we could get 4 going up and down. All right, so if we could get 25 across the bottom and 4 going up and down to fill the entire box, it would be 25 by 4, or what? 100 boxes. So 25 to fill the bottom, and then we would have 4 stacks of those 25, right? This would be 25, this would be 25, that would be 25, and that would be 25. So the answer to part A would be 100. So I'm going to go ahead right here for part A, and I'm going to type in 100. All right. Alrighty. So now let's go ahead and look at part B. Part B says the company plans to increase the width and the length of the large box by 4 inches each. So if we go back to where we were, all right, so now I'm going to go ahead and erase all of this. Okay, so our larger one is still going to be, what was it? It was 16 inches tall. So this is still going to be 16. But it was 10, but now they're going to increase it by 4. So 10 plus 4 is 14, and 10 plus 4 is 14. So our new larger dimensions are 14 by 14 across the bottom, and 16. So now if I go over here to change this, that's no longer 10, and that's no longer 10, which means that's no longer 5, and that's no longer 5. What is it? It's 14. 14 divided by 2 is 7. 14 divided by 2 is 7. So now instead of 5 across, we're getting 7 across, and instead of 5 deep, we're getting 7 deep. And so instead of having 5 times 5 is 25, we have 7 times 7 is 49. Now, they did not change the height. So going up, do you remember what we had? We had 16 divided by 4 is 4. So going up, we're going to have 4 stacks of 7 by 7. So instead of having 25 times 4 to equal 100, we're going to have 49 times 4. Now 50 times 4 would be 200, but if we take away 4 of those, we get 4 times 4 is 16, so we get 186. All right. By the way, this problem did have a calculator available, so any of these calculations you could have used the calculator. So again, I encourage you to do a lot of math without a calculator, but say you wanted to check that last one, 49 times 4, you weren't quite sure. It's 196, and what did I say that it was? I said that it was 186, right? So it's very important that we are checking our math, right? We don't want to get it wrong, to do all that work and get it wrong because the math teacher can't do math. That would be truly horrible. So 196 is the second answer we were looking for. So glad we used the calculator to check our answers. All right, question number 25. Here we go. Lenny bought a motorcycle. He paid 12.5% in tax. Wow, that's a lot of tax. The tax added $1,437.50 to the price of the motorcycle. What was the price of the motorcycle, not including the tax? All right, so what we have here is we have a motorcycle. I'm kind of tempted to draw a motorcycle, but my artistic skills leave much lacking. So we have the cost of the motorcycle, right? Motorcycle. The original. Did I spell that right? Motorcycle. There we go, right? So we have the cost of the original, right? Plus we have the tax. And that would give us the final, or let me say this, that would give us the total cost. Now, what did they tell us? They told us that that tax was 12.5%, and they told us that that tax was 1437.50. And what did they ask us to find? The price of the motorcycle, not including the tax. So that is what we are trying to find. So what can we do here? Well, 12.5% is 1,437.50, but 12.5% of what? 12.5% of the original cost. I'm going to put OC for original cost, okay? OC, original cost, is equal to $1,437.50. 12.5% of the original cost. But what is that original cost? We don't know what it is, right? But it would be 12.5, and I'm going to call it X. So 12.5 times what we don't know is $1,437.50. So how do you solve this equation? How do you find out what that is? Well, this is a one-step equation, and the opposite of multiplying by 12.5 is dividing by 12.5. But wait a second. 12.5% needs to be changed to a decimal. When you're going to be doing math with percentages, you need to change it to a decimal. And how do you do that? By moving the decimal 2 places to the left. So 12.5% as a decimal is going to be 0.125. 0.125. Because what we're looking for is 12.5 over 100. All right, and when you divide by 100, you move it 2 places. So it's not actually going to be 12.5 times that. It's going to be 0.125 times that, which means I'm going to divide by 0.125, not by 12.5. All right, so we want to do $1,437.50 divided by that 12.5%. Well, luckily, they gave us a calculator, and I'm just going to dive right in and do it. All right, so we have 1,400. Oh my goodness, I already forgot what it was. I am losing it. Here we go. Whoops. 1437.50. 1437.50. That was the cost. that was the tax, excuse me, divided by 0.125. Thankfully, I didn't remember 12.5%. And what do I get? I get 11,500. 11,500. All right, so 11,500 was the cost of the motorcycle before tax. So they didn't ask us for the final cost or the total cost, but the total cost would be those two added together. And if we wanted to check our answer, we could take this 11,500, we can multiply it by the 12.5% and see if we actually do get that answer. So why don't we do that? 11,500. So 11,500. Whoops. Clear all, shall we? Let's clear it all. 11,500. That's the cost of the motorcycle, we're saying, times 0.125 or 12.5%. And we do get that number. I was having a hard time remembering earlier, $1,437.50. So the answer we're looking for is $11,500, of which 12.5% is $1,437.50. All right. All right, question number 26. Here we go. These two maps show the same area at two different scales. Columbus is not on map A. So you see map A, there's Columbus, there's no Columbus. Map B does not have a scale written on it. See, there's a scale on map A, there is no scale on map B. Riverside and Gladville are 6.8 meters apart on map A. So if I were to go ahead and connect these 2 points here on map A, I get 6.8 centimeters. And if I were to connect those same two cities on map B, I get 3.4 centimeters. All right, now there's something we need to know. The actual distance between Riverside and Gladville never changes, right? Which means if these maps are to scale, and they're telling us they are, then these two numbers represent the same distance. This one represents it in 6.8 centimeters. This one represents it in 3.4 centimeters. So I have a question for you. How many times bigger is the scale on map A than map B? What do you have to do to 3.4 to get 6.8? Or if I were to write 6.8, which is the distance on map A, and I were to divide it by 3.4, which is the distance on map B, I hope you can quickly see that 6.8 divided by 3.4 is 2. So map A has twice the scale of map B. Got it? Or you could say map B has half the scale. Its scale is half as big as map A. All right, so what else did they tell us? They told us on map B, all right, so map B right here, they told us on map B that Gladville and Columbus are 1.8 apart. So that distance right there is 1.8. So again, Columbus is not on this map. So I'm just going to do a quick sketch here. Again, this is not necessarily exactly where it would be. I know it's not exactly where it would be. But the question is, what would that distance be on this map? Well, what do we know? We know that map A has to be what? 2 times bigger than map B. So if this is 1.8, then this should be 1.8 what? Times 2. And 1.8 times 2 is 3.4. Got it? 3.6. All right. So, but what does the question actually ask us? By the way, these are centimeters, 3.6 centimeters. What does the question actually ask us? The question says, determine the distance in miles from Gladville to Columbus. So if you were tempted to put 3.6 in there as the answer, as I was, we would get it wrong, even though all our math is correct, because the question doesn't say, what is the distance on map A in centimeters? It says, determine the straight line distance from Gladville to Columbus in miles. So now we actually have to take a look at this scale. And what does it say? 1 centimeter is equal to 40 miles. So we have 3.6 centimeters, right? We have 3.6 centimeters on the map. But each of those centimeters is equal to 40 miles. So the centimeters needs to be multiplied by 40, right? So we need to do 3.6 times 40. And actually what we're multiplying is by miles per centimeter. So then the centimeters would cancel, and that's how we would get miles. All right, so again, we could do 40 times 3.6, and we could do it that way. Or, since we have a calculator available, we could do 40 times 3.6 that way. So why don't we do that? We'll go ahead and do 40 times 3.6, and when you do 40 times 3.6, you get 144. So the actual distance in miles is 144. And since they said in miles, they put the units. Again, when they put the units in the question, you don't have to put the units in the answer. When they put the units in the question, you don't have to put the units in the answer. Those two cities are 144 miles apart. Now, of course, I could then go ahead and ask you then, well, what is the distance between Riverside and Gladville? And we could figure that out. But that's not in the question. So we will move on to our last question for this video, question number 27. All right, Johnny uses a wheelbarrow to move planting soil to a delivery truck. Doesn't this sound like fun? The volume of the planting soil that fits in the wheelbarrow measures 2 feet by 3 feet by 1.5 feet. The delivery truck measures 11 feet by 8 feet by 6 feet tall. Johnny puts planting soil in the delivery truck until the delivery truck is 70% full. What is the minimum number of times Johnny needs to use the wheelbarrow until the delivery truck is 70% full? All right, so let's make a couple sketches here. So I'm going to, oh my goodness, that's horrible, Mr. Reeves. That's not much better. Why am I having so much trouble with 2 E's? E, E, there's wheel, barrow. Have you ever wondered about that word, wheelbarrow? It's kind of a weird word, isn't it? All right, so the wheelbarrow is 2 feet by 3 feet by 1.5 feet. And the volume, when you have length times width times height, the volume is just that. It's length times width times height. So it's 2 times 3, which is 6. 6 times 1.5, well, 6 times 1 is 6. So the volume for that is 9 cubic feet. So the wheelbarrow can hold 9 cubic feet. All right, then we have the truck. The truck is 11 feet by 8 feet by 6 feet. All right, so that's going to be 88 times 6. And again, we could do that by hand, or we can go to our handy dandy calculator, and we can do 88 times 6, and 88 times 6 is 528. 528. All right, so 8. So this one is 528 cubic feet. So if they just simply asked us how many wheelbarrows would it take to fill up the truck, do you know what we would do? We would do 528 divided by 9. 528 divided by 9. So if again I went back to my handy dandy calculator and I cleared it all out, I've learned my lesson. 528 divided by 9, that would mean that he could get 58.66667, or hopefully you know that that would be equivalent to 58 2/3 wheelbarrows. That's if it were 100% full, right? 58 2/3 wheelbarrows. But what percentage did they want? They didn't want 100%. They wanted what? They only wanted 70%. 70% what? They want 70% of the truck's volume, right? Well, what is 70% of the truck's volume? Well, what was the truck's volume? 70% of 528, right? So remember, we're going to change that 70% to 0.70. So 70% of 528 is going to be 0.070 times 0.70 times 528. All right, so here we go. So let's clear this out. And we're going to go 0.70, or 70% times 528. And we get 369.6. So 369.6, actually 369.6 what? Cubic feet is 70% of the truck's volume. Right? All right. So remember before when we were doing the entire truck's volume, we did, do you remember what we did? We did 528 divided by what is the volume of the entire wheelbarrow? 9, right? Now what are we going to do? Now we're going to do 369.6 divided by 9. This was for 100%. This is going to be for 70%. So we're almost done. So what do we want to do? We want to take that answer that we have, right? And we want to divide that answer by 9. So I'm going to take that answer and I'm going to divide it by 9. And I get 41.0000, 41.0666667. All right, or about 41, right? So what is the minimum number of times Johnny needs to use the wheelbarrow until the truck is 70% full? The minimum number of times he needs to go. It's really, really close. I'm wondering on here what they want us to do because it's so close. 41.1 if we rounded. So it would take 41.1 wheelbarrows. So if we did exactly 41, actually, what would happen? It would be too small. So let me try this. Let me try that number again, just to make sure. I'm doubting myself here a little bit. So we have 528 times 0.70, and we get 369.6. So I'm going to go 369.6, and I'm going to divide it by 9, and I get 41.1. So it would take 41.1 wheelbarrows. So If they said round to the nearest wheelbarrow, it would be 41. But if it's the minimum number, if he does 41, he's going to be just below 70%, right? So I would say the answer to put would be 42. Although I'm not really sure if they wanted 41. I'll tell you what, this is what I'm going to do. I'm going to go back after this video is done, and I'm going to check the answer key. And if they put 41, I'm going to bring it up in the next video. But honestly, doing the math, 42, if you did 41, it would be just less than 70%. If you do 42, it's going to be over, but it says what is the minimum number until it is 70% full. At 41, it's not quite 70% full. All right, so I'm going to stop there now. Thanks for watching. I think we just have one more video to go till we make it. All right.